Hi students, welcome to Max Point of View. Today we are going to solve each and every theory question from the chapter Household Circuits, that too part A. Before starting this video, my suggestion is watch the concept video first. If you have watched the concept video, then this video will be very easy for you, or else you will definitely struggle. That video will be available in the description box. At what voltage and frequency is the electric power generated at the generating station? So they are asking us to write the what voltage we are generating at the generating station. The voltage will be generated, okay, voltage, generated voltage will be 11 kilovolt, okay. K should be small, keep that in mind, okay. Then they are asking us for to write the frequency. See, throughout India, so we are talking especially about India, so frequency in India will be 50 hertz. Hertz is the SI unit of frequency. That's it. Our next question, at what voltage and frequency is the AC supplied to our house? See, when they are talking about voltages, okay, it is different in different cases. At the power generating station, it is 11 kilovolts, but they are asking, this question is about houses. For our domestic purpose, how much voltage we are receiving from it, okay. The voltage to house or domestic purpose, anything is fine, that will be 220 volts. And the frequency, see, the frequency at the generating station, okay, frequency will never change. Whatever the frequency we are receiving from the generating station, that will be equal to 50 hertz, and that is what we are receiving at our home also. Our next question, name the device used to increase the voltage at generating station and decrease the voltage at substation for its supply. Listen, we know to increase or decrease we need a transformer, whether to increase the voltage or decrease the voltage, but specifically they are asking what type of voltage to increase. See, why, how we can increase or decrease the voltage? Because of the transformer, and they are asking what type exactly. So for sub question A, we need to increase the voltage, right? So it is called as step up transformer, okay. To decrease the voltage, it is very simple, step down transformer. In the exam, if you just write transformer, you will never get marks, okay. They are specifically asking to increase the voltage, it is step up transformer. To decrease the voltage, it is step down transformer. Our next question, in what unit does the electric meter in a house measures the electrical energy consumed? What is its value in SI units? Very simple. Listen, what is the electric meter? Many times they'll use different words. So electric meter, right? We are talking about electric meter is nothing but kWh meter, okay. So in this meter, see, both the words you should know, because in the exam we don't know which word they are going to talk about. So all these things you should know. Electric meter or kWh meter, they are asking what unit we are using to measure the readings in our domestic purpose or anywhere. That is nothing but unit we are measuring will be kWh, kilowatt hour. This is the unit we are reading. Every time we are noting all the values in the terms of kWh. This is called as 1 unit. So okay, 1 unit means 1 kilowatt hour. Keep that in mind, because in all the electricity bill, all the bill will be generated for 1 unit. 1 unit means 1 kilowatt hour. Now we have to convert this into SI unit. 1 kilowatt hour. See, this we have learnt in electricity concept itself, current electricity, correct? So 1 kilowatt hour is equal to 3.6 into 10 power 6 joules. This is the SI unit of energy consumption, and this is the unit we are using in our houses. Our next question, where is the main fuse connected in house circuit? I know there are many fuses we are using. See, if you have understood the concept video, this is very easy. If you have seen this, if you are seeing this one for the first time, definitely it will confuse you. So my suggestion is watch the concept video first. Listen, where is the main fuse? There are two different fuses we are using. Company fuse or pole fuse, both are same. That is different. Main fuse is different. Our next question, how should the several electric lamps be connected with the main so that switching on or off a lamp has no effect on the operations of other lamps? Assume, see, first you need to understand the question. Assume there are these, assume these lines are nothing but different lamps. Okay, several electric lamps. Assume these are the several electric lamps. So now I need to turn off this one. I need to turn off this one. So whatever I do, it should not affect any of the remaining electric bulbs. So how these should be connected? This is what we learnt in earlier question also. That is nothing but if you connect it in series, okay, if you turn off this one, everything will be turned off. If you turn on this one, everything will be turned on, correct? So it should be connected in parallel. So answer for this question is parallel. So when you connect in parallel, separate fuse and separate switch can be given, correct? For this electric lamp, separate fuse and separate switch can be given. So if I turn off this switch, there will be no effect on the remaining bulb, because these bulbs will have separate fuse and separate this one switch. So it should be connected in parallel with separate switch and separate fuse. Our next question, at what voltage is the electric power from the generating station is transmitted? See, at what voltage we are generating, that is 11 kV. The transmission also will happen in 11 kV, and they are asking give reason for your answer. So what do you mean by that? Very simple. Listen, if why we cannot produce, why we cannot generate more than 11 kV, that is their question. So first we have two sub questions. In that first sub questions, at what voltage we are transmitting the power, that is nothing but 11 kilovolts, and they are asking for the reason why we cannot generate more than 11 kV. It will cause insulation problem. Okay, this is the reason why we cannot generate more than 11 kV. Next, we have one more sub question, that is nothing but what is the nature of current transmitted from the power station? What is the nature? What do you mean by that? What kind of current? There are two types of current, AC current and DC current. What are the type is nothing but the nature of current. So what is the nature of current? That is AC. Okay, see, in exam if you write this much also, you will definitely get marks. So don't write the stories in the exam, just the precise answer. See, what is the power transmitted power in terms of voltage? 11 kilo. That's it. You don't have to write it in the form of sentence also. Then what is why we cannot produce more than 11 kV? It causes, okay, it causes insulation problem. Then second part we have, they are asking the nature of current, AC, that's it, or if you want to be precise, alternating. Current, that's it. Our next question, the voltage of power generating at the generating station is first stepped up before its transmission, give reason. So before answering this question, you need to know what is stepped up. Stepped up means increasing in voltage. Step down means decreasing voltage. So before transmitting the voltage, whatever the generated voltage, okay, listen, what is the generated voltage? That is 11 kV. Okay, the generated voltage is 11 kV and they are telling before transmitting it is stepped up. That means the voltage is increased. This is only a high voltage. Then why they are increasing it? See, while transmitting 11 kV, that is nothing but generated power or voltage, generated voltage, huge loss of energy in the form of heat. Okay, there will be a loss of energy. So while transmitting 11 kV, huge loss of energy, there will be a huge loss of energy in the form of heat. So it is stepped up. So if you step up, the voltage will increase. If the voltage increases, even though there is a loss, okay, loss in the form of heat energy, then also we can get 11 kV at the destination point. Our next question, name the 3 connecting wires used in household circuits, and we have 2 more sub questions. First we will answer this sub question. Okay, name the 3 connecting wires. Live wires, see, live wire or line wire, anything is fine. Live or line, both are same. Neutral wire and finally earthing wire. So these are the 3 wires which we are using in our houses. Everywhere, wherever we go, we use these 3 wires only. See, first thing you need to understand what is the function of live wire, what is the function of neutral wire, what is the function of earth wire, and where this is connected, where this is connected, and where that is connected. All those things you should know. That is what we have learned in concept video. That is why I am suggesting whenever before you solve the theory questions, you need to understand the concept. Once we can understand all these things, if we have numericals, we can all solve it. So to solve all the theory questions, we need concept. If you have understood the concept, these kind of questions will be very easy, right? So my suggestion is always first learn the concept video. That is also available in for all the chapters, concept video. First you learn it, then you go for solving the theory question, then it will be very easy. Okay, now listen, we'll go for the second sub question. Which 2 wires mentioned in part A are at the same potential? That is nothing but that is what we have learnt in concept. Neutral and earthing. Neutral and earthing wires have same potential. That's it. See, you don't have to write it in the form of sentence also in the board exam. This is enough. See, this is what they will give us as a key answer. If you have written for question number B, neutral wire and earthing wire, done, you will get full marks. You don't have to write it in sentence form also. Neutral and earthing wires are at the same potential. Those things also you don't have to write. This is the answer we are looking for. Keyword is enough for us. Okay, if it requires, if they are asking give reason, then you have to write it in the form of sentence. If they are asking particularly a specific answer, if you are looking for specific answer, the keywords are enough. Now we'll go for one more sub question. In which of the wires stated in part A is switch is connected? Always the switch is connected to the live wire. Live wire, you can also write it as line, L-I-N-E wire. So both are same. Most of the time we use live wire. That's it. Our next question, what is the pole fuse? Write down its current rating. It's a very simple question. This is what we have learned in concept video. Listen, what do you mean by pole fuse? Pole fuse, the word pole represents something, fuse represents something. Fuse is a device. Okay, pole, it represents the cable connection. See, I'll teach you. See, before connecting the cables, before connecting the cables from the pole to the meter board of a building. A fuse is connected. Okay, to the meter board, a fuse is connected first. This fuse is called pole fuse. I know you did not understand anything. Listen, assume this is the cables we are receiving. Okay, from the company. What company is that? Service provider. That is nothing but, assume it as Bescom. Okay, there are many service providers. Now just for an example, we are taking as an example of Bescom. See, whenever we are getting the connection, assume you are building a new house. Now you need a connection. The connection will come from the pole. The cables, see, before connecting the cables from the pole, so from the pole, before doing all the connection, the meter board, see, the meter board. Okay, meter board means where it can generate the electricity bill. How much reading, based on that reading only electricity bill will be generated. So this meter board and the cable from the pole is connected, okay, through a fuse. This fuse is called as pole fuse. Now you understood. See, before connecting the cables from the pole to the meter board of a building, a fuse is connected first. This is called as pole fuse. This has one more name. It is nothing but company fuse. They can confuse you with any word. Pole fuse and company fuse, both are same. See, we are not supposed to operate this company fuse. If you don't pay the electricity bill, they'll just take out this fuse, then you have to replace it with a new one, but before replacing you have to pay the electricity bill. This is the concept. So if you understand like this, there is no need to by heart anything. That's it. We have one more sub question. Write down its current rating. Current rating means the maximum current it can withstand. That is nothing but, for this, see, the current rating of all the fuses are not this value. Okay, it is 50 amperes. Current rating of all the fuses are not 50 amperes. It is only for the pole fuse or company fuse. That is based on the application we are going to write the current rating. So current rating of pole fuse or company fuse is 50 ampere. Our next question, state the function of each of the following in housing circuit. First one, kVH meter. Okay, we have two more sub questions. First we'll go for kWh meter. Okay, listen, see, first if you know the connection diagram, then it is easy to understand all these things. Listen, a wire will come from the company. This will be connected to a fuse. Okay, this will be like this. Fuse, from the fuse, meter board is nothing but kVH meter only. kWh meter. Then it will be connected to main switch. This will be fuse. This fuse is nothing but pole fuse or company fuse. This is how the connection will be. Okay, now they are asking what are the functions of this. If you know these kind of diagrams, you can write it in the exam, or else you will write something else. For something else they will never give marks. Keep that in mind. Okay, so kWh meter, what is the function of this kWh meter? See, from the kWh meter only all the connections will be running. So all the wires from the kWh meter only will be connected. And what is the function of it? To note down the readings of energy consumption. See, how much energy we are consuming, those will be noted down in the kWh meter. Based on this only we are going to get the electricity bill. Second one, main fuse. Okay, main fuse. See, why we are using the main fuse? In order to safeguard the appliances from high current. If high current comes, we know we are using AC current. AC current means alternating current. The value of that AC current will not be constant all the time. It will be keep on varying. If there is any fault, if the high current comes, in order to the main fuse, what is the function of this one? In order to safeguard the appliances from the high current, then we'll go for the main switch. See, what is the function of main switch? See, the function is very simple. It is used to break the connection of live and as well as neutral connection simultaneously. See, main switch, it will be like that. Okay, so main switch is double pole switch. Double pole switch means you can connect it like this or you can connect it like this. You don't have to worry about it for now. If you have understood the concept video, it is well and good. Now listen, what is the function of main switch? It is used to break the connection of live as well as neutral wire simultaneously. Both at the same time we can break the connection of live wire as well as the neutral wire. Our next question, state one advantage of using main switch in house wiring. We have learnt one of the functions in one of the questions, correct, in the same video, and that can also be an advantage. Listen, they are asking for an advantage, right? First advantage, main switch, it will protect appliances from electrical fault. Then it can break both live and neutral wire connection simultaneously. So these are the two advantages of main switch. It will protect the appliances from electrical fault. This is one of the advantage. You can break, okay, you can remove the connection of both live wire and neutral wire simultaneously. These are the two advantages of main switch. Our next question, two sets A and B of each 4 bulbs are glowing in separate rooms. When one bulb is fused in set A, okay, the other 3 bulbs will also cease to glow. What do you mean by cease to glow? Means that everything will stop working. But in set B, when one bulb is fused, the other bulbs continue to glow. See, in series connection we know if one get damaged, everything will not work. That is nothing but set A. So set A, we need to know, listen, in set A we need to know they are connected in series, set B are connected in parallel. How we can come to this conclusion? If see, they are telling when one bulb in set A is fused, the other 3 bulbs are cease to glow. See, what do you mean by cease? Stop to glow. So that means everything is connected in series. But in set B, if one bulb is fused, Okay, other 3 bulbs continues to glow. So this is connected in series and this is connected in parallel. This is not the answer we are looking for. This is how we can come to the conclusion. Now we'll go for sub questions. Okay, first one, explain the difference in 2 sets. That is nothing but this one. Set A is connected in series. Set A, series connection. Set B, parallel connection. So this is the answer for first one. Second one, which set of the arrangement is preferred in housing circuit and why? Very important question. See, which connection you prefer? In set A, if one bulb is as a problem, that means everything stopped glowing. We won't recommend set A. Set B is the recommendation. Is the recommendation because what are the advantages of parallel connection? That you can write it here. So that we have learnt it, right? So advantages of parallel connection, what are the advantages? First thing, every bulb will receive maximum voltage or rated voltage. Anything is fine. Will receive rated voltage. That is nothing but 220 volts. Every bulb, see, if it is connected in parallel, every bulb will receive 220 volts. But if it is connected in series, how many bulbs are there in series? Set A, 4 bulbs, correct? How much voltage we are sending? 220 volts. So set A, every bulb will not receive 220 volts. 220 divided by 4. Each bulb will receive 55 volts only. Then there will be no intensity. So the intensity is nothing but the brightness will be very less. So in parallel connection, every bulb will receive the rated voltage, that is nothing but 220 volt, and other bulbs works normally if any one bulb is fused or damaged. That's it. Our next question, explain with an aid of simple diagram the transmission of electric power from the generating station to your house. We need to draw the block diagram. See, it will always start from the generating station. Okay, and we know what is the power or voltage we are generating at generating station, that is 11 kilovolt, correct? This is the starting point. If this is wrong, no marks will be allotted for the remaining diagram. Okay, listen. So what is this value is very much important. In all the blocks, the values are very much important. So once the power is generated, this will start transmitting. So we understood in the previous question that before transmitting it needs to be stepped up. So this voltage should be stepped up. Stepped up means increased. Why? There will be a loss of energy. To see, we know we cannot avoid that loss of energy, that will be definitely there. So in order to get this much voltage, so it is stepped up. So once the value of voltage is increased, whatever the loss is there, that will be lost in the increased voltage. We are definitely going to get this one only. Okay, in the grid station, okay, it is stepped up. This is very much important. Stepped up to 132 kilovolt. See, from 11 to 132 kilovolt it is increased. Okay, now this one is given to the main station. Now it is stepped down. See, we don't require 132 kilovolts. Okay, why we have to increase it to 132 kilovolts from 11? In order, we know there will be a loss, and that should not be happen with the 11 kilovolts. That's why we are stepping it up. So, and we don't require 132 kilovolts. Now it is stepped down to 33 kilovolts. 33 kilovolts. Okay, why we need to exactly step down to 33 kilovolt? See, stepping up and stepping down always based on the transformer. We are going to learn about the transformers in the next chapter, electromagnetism. For now, don't worry about it. You just need to know. See, the stepping up and stepping down is based on the this one, transformer. Don't worry about it. Stepping up means increasing in the voltage, stepping down means decreasing the voltage. So my question is, why we need to step down exactly to 33 kilovolts? Why? Because it is given to, okay, it is given to heavy industries. Okay, it is given to heavy industries directly. Heavy industries like car production, all those things requires high voltage, so it will be given to heavy industries. Then again this will be step down, okay, step down to intermediate station, and again it is step down to 11 kilovolts. So in the intermediate substation, again it is step down to 11 kilovolts, and this will be given to light industries. Light industries. Then again it is step down in the one of the substations, the city substation. Again it is stepped down to 220 volts, and this will be given to your house. That's it. So this is the block diagram they require. Our next question, draw a circuit diagram to explain the ring system of house wiring. State two advantage of it. Listen, this chapter and electricity chapter, electromagnetism and sound chapters, almost all the chapters in physics, you need to understand the concept properly. If you don't understand the household circuit and electricity, then you cannot answer any logical argument type of questions. Okay, listen, first you need to understand the diagram. Listen, we know we'll get three different wires from the this one main board, correct? From the main board it is connected to main fuse. See, main fuse nowadays you can also write it as MCB, main fuse. Okay, miniature circuit breaker. Okay, anything we can use. But nowadays we are not using main fuse, we are using MCBs. Okay, listen. So the live wire, see, this will tell us, this upward and down movement tell us only the live wire is connected to the main fuse. Only the live wire, neutral and earth wire will not be connected to the main fuse. It will be directly moving. Now this shape will tell us this is not connected to this wire, this is jumped and connected to this wire directly. So this jumping, okay, the shape tells us this wire, okay, this wire is not connected to this wire, this is connected to this wire. That's it. Okay, listen. So whenever you don't have to connect this wire directly to this one, you just have to do like this, then only you will get the proper answer. Okay, listen. So this is the connection. Now this is the ring system. Okay, very simple. Listen, if you take one, assume we are connecting a lamp. What does a lamp require? Lamp does not require huge current, okay, or huge power, correct? A small power is enough to lighten the lamp, so it does not require earthing connection. Wherever you require huge power, there we require earthing connection, like a fan, okay, this one machine, washing machine, all those things require earthing connection because they use huge power. Wherever we are not using huge power, a small power, no earthing connection is required. For a lamp there is no earthing connection required. Listen, So from the live wire, see the live wire, all the switches, see we have learnt in one of the questions that the fuse is connected or live wire is connected to the switch. Keep this in mind. Fuse and live wire should be connected to the switch. See, this is the live wire, correct? From the live, okay, it is connecting directly. So this is the live wire, the second one is the this one neutral wire, the innermost wire is called earthing. So for a lamp, okay, or a bulb, it does not require earthing. By where we are using the earthing connection, where we require huge power, there we are using the earthing connection. For a lamp, it does not require earthing connection. Only two connection is required, neutral and live. For a switch and fuse, live wire is connected. One more wire coming from the negative end of the bulb is connected to the neutral. That's it. So if you have a this is socket, normal socket, if you have a 3 holes, one wire is connected to the neutral, okay, the bigger one, the bigger one is connected to the earthing, and the right side one is nothing but the live wire connection. So the switch and fuse should be connected to the live wire. That's it. So now here, if you connect washing machine here, you can use washing machine. If you connect fan, you can use fan. Anything which consumes more power, that requires earthing connection. That you keep in mind. Okay, now this is the ring connection. If you write this much, that is enough. Our next question. Draw a label diagram with a necessary switch, regulator, etc. to connect a bulb and a fan with the mains. In what arrangement are they connected to the mains, whether series or parallel? Very simple. The same diagram which we drew for this one ring system, the same diagram they are looking for. Bulb we used in ring system, and there was a socket, correct? Instead of socket, you can write fan. That is enough, because fan requires huge power, so there will be an earthing connection also. The same ring system, instead of the socket, you are going to write the fan. And there is one more question: in what arrangement are they connected to the mains, whether series or parallel? It is always connected. All the appliances are connected in parallel. Why? Because see, in series connection means if there is a problem in one appliances, then there will be problem for all the appliances. If you connect it in parallel, if there is a problem in one appliance, we can sort it out separately. All other appliances will work normally. So all the appliances are connected in parallel. All the appliances, not all the switches, all the fuses, all the appliances are connected in parallel. Our next question. Figure shows 3 bulbs A, B, C, each of rating 100 watt and 220 volt connected to the mains 220 volts. Answer the following. Listen, whenever they talk about power 100 watt and 220 volt, don't worry about it. That means this this is made up of 100 watt capacity, and requires 220 volts bulb to glow properly. Okay, if you give less voltage, the brightness will be, the intensity of light will be less. If you give the proper voltage 220 volts, then it will glow in a high maximum intensity. That is the meaning of 100 watt. 100 watt means the capacity, the power of this bulb. 220 volt means it requires 220 volts to give the maximum intensity. If you give less than 220 volts, the intensity of the bulb will be less. So these things you should know, because whenever they give you the values, you should not always think of calculating something. You should know the meaning of those values. Okay, listen. Now we'll go for first question. How is the bulb A connected with the mains? This is bulb A and this is the mains. See, this symbol represents AC and this symbol represents DC. All these things you should know. These are the basics of electricity. Okay, this is what we have learnt in electricity concept, and this now we are talking about mains. So this symbol represents AC, this is DC. Now the complete AC, this one household circuits, we are going to use only AC, not DC. Okay, in current electricity we learnt about the cell, electromotive force, that is completely based on DC. Now we are going to use AC connection. Listen, AC, how the bulb A is connected to mains. See, if you have seen the electricity concept, and if you know what is series and parallel connection, aram se you can answer it. Bulb A is connected parallelly. with means. Okay, and there we have one more sub question in A. At what voltage it glows? We know in parallel connection voltage will not divide, voltage will be same. Keep that in mind. This is what we have learnt in basics of electricity. That is very much important. Okay, before watching this video, if you have seen those videos, then definitely few things will be helpful. So if it is parallel connection, whatever the voltage we are getting, how much voltage they are giving, that is 220 volts. So if it is parallel, the same 220 volts we are going to receive. So that will be 220 volts. Then sub question B. How are the bulb B and C are connected with the mains? See, these two are connected in series. These two are connected in series. Connected in series with main. So in parallel connection the voltage remains same. Okay, in series connection voltage divides. So how many bulbs we have? 2 bulbs. What is the voltage we are getting? 220. 220 divided by 2, that will be 110 volts. So for each bulb 110 volts will be supplied. Okay, if there are 5 bulbs, then 220 divided by 5, so each bulb will get 220 divided by 5. So now anyhow we have only 2 bulbs, 220 divided by 2, that will be 110 volts. That is what each bulb B, C are receiving from the mains. Now how is the glow of A and C affected if the B is fused? Listen. How is the glow of A and C affected if the B's get fused? B get fused means B get damaged. Assume this get damaged. We know in series connection, if this get damaged, there will be no power for this one. So B in sub question C, bulb C, okay, will not glow. And for bulb A, see, bulb A, how is it connected with the mains? It is parallel. Even though there is a problem here, this will never affect this one. That is the main advantage of parallel connection. So if you know what is parallel, if you can identify which is parallel, which is series, then only we can answer this kind of question. If you don't know that, that means you have not learned the electricity part B. That is where we are going to learn series or parallel. See, whenever something is connected in series, see, these two are in series, right? If this is get affected, there will be no power for this one. And A is connected parallelly with mains. If this is get affected, there will be no effect on A. So bulb A will glow normally. That's it. So now we have solved each and every theory question which is there in household circuit part A. So we have learned the concept video. After that we are solving these theory questions. So now we are going to learn the concept video of part B. See, this is how you have to learn. First learn the concept video, then go for the theory solution. After that go for the numerical solution if that part has a numerical. Okay, then only you can understand everything. If you leave one of the concept, then you know the complete paper, okay, the complete paper will be of 90% logical questions. So you should know the basics. Once you learn the basics, then only you can go for logical questions. So my suggestion is first watch concept video, then go for theory solution. After that numerical if you have. Thank you.